Yesterday evening at 9 p.m. Eastern Time, a team of scientists published measurements that definitively end the 5-month debate about interstellar comet 3I Atlas. What they discovered using spacecraft positioned millions of miles apart answers the alien technology question once and for all and reveals something more profound about the universe. Welcome back. Since July, we've been following the controversies surrounding 3I Atlas, the third confirmed interstellar visitor to our solar system. We watched Harvard's Avi Loeb propose a 40% probability of alien origin. We saw NASA mobilize 20 spacecraft for the largest observation campaign in history. And we asked ourselves, what is this object really? On December 16th, researchers led by Marshall Eubanks released their findings in Research Notes of the American Astronomical Society, a study that changes everything we thought we knew about measuring interstellar objects. And today, we're looking at what they found. The method they used is revolutionary. Long baseline astrometry. NASA's Psyche spacecraft and ESA's Mars trace gas orbiter, positioned millions of kilometers apart in different locations across the solar system, simultaneously tracked 3I Atlas as it moved through space. That triangulation allowed them to measure velocity changes with unprecedented precision, detecting accelerations of just a few hundred millionths of Earth's gravity. To put that in perspective, previous interstellar visitors like Oumuamua in 2017 were gone before we could achieve this level of accuracy. With 3I Atlas, we had months, and we had spacecraft in the perfect positions, a once-in-a-lifetime opportunity. What the data revealed exceeded expectations in its clarity. The non-gravitational acceleration of 3I Atlas measures exactly 5 times 10 to the negative 7th meters per second squared. That number might sound technical, but here's why it matters. That acceleration rate is identical, mathematically identical, to what we observe in dozens of small comets right here in our own solar system. When sunlight heats a comet's icy surface, frozen material doesn't just melt, it explosively vaporizes, jetting gas and dust into space. Those jets act like tiny rocket thrusters, giving the comet small but measurable pushes that alter its trajectory. This is called outgassing, and it's one of the most well-understood processes in planetary science. But the team didn't stop at acceleration. Using their measurements combined with carbon dioxide outgassing rates detected by other missions, they calculated 3I Atlas's actual physical properties. Mass, 44 million metric tons, radius between 260 and 370 meters. Those numbers place this interstellar visitor squarely within the normal range for small comets throughout our solar system. Not exotic, not anomalous, completely ordinary except for one crucial detail. It came from another star. And here's the fascinating part. Every single anomaly that Avi Loeb cited as evidence for possible alien technology, the unusual acceleration pattern, the trajectory alignment, the chemical composition differences, this study addresses them with hard measurements. The acceleration, natural outgassing, identical to our comets, the trajectory, normal gravitational physics plus those tiny jet pushes, the chemistry, to expected variation for objects that formed in different stellar environments billions of years ago. All of it checks out as completely natural. But where does this precision come from? This is more significant than it first appears. The research team accomplished something that wasn't possible even 5 years ago. They combined data from spacecraft across the solar system, Parker Solar Probe observations from near the Sun, Mars orbiter measurements during the close flyby, Jupiter-bound missions tracking from the outer system, and critically, those two spacecraft positioned millions of kilometers apart, creating a baseline longer than Earth's entire orbit. That geometric advantage is what gave them the precision to detect such tiny accelerations. Think about that coordination. NASA, ESA, private observatories, all sharing data in real time, all calibrating their instruments to track a single object moving at 130,000 miles per hour through our neighborhood. What do you think? Does proving this is natural make the discovery less interesting or more fascinating? Write your estimate in the comments, because here's my perspective. We just confirmed that a chunk of ice and rock formed around a completely different star, potentially hundreds of light years away in a molecular cloud we'll never see, follows the exact same laws of physics as objects in our solar system. The chemistry works the same, the orbital mechanics work the same, outgassing behaves identically. This isn't just about one comet. This is proof that nature is consistent across interstellar distances. The timing of this publication is remarkable for another reason. 3I Atlas made its closest approach to Earth just 3 days ago on December 19th at 170 million miles distance. Right now as we speak, it's already accelerating back toward interstellar space at over 200,000 kilometers per hour. The window for observation is closing. In a few weeks, it will be too faint for most telescopes. In a few years, it will cross beyond Neptune's orbit. And in a few thousand years, it will leave our solar system permanently, returning to the darkness between stars. We got our measurements just in time. Why do we care so much about these precise numbers? Here's what the study doesn't say loudly but implies. This was a test of our ability to rapidly characterize unknown objects entering our solar system. The techniques Eubanks and his team developed, using widely separated spacecraft for baseline measurements, detecting minute accelerations that reveal an object's true nature, these methods will be crucial for future visitors, and there will be future visitors. Statistical models suggest dozens of interstellar objects pass through our system every year, most too small or too distant to detect. But with next-generation surveys like the Vera Rubin Observatory coming online, we'll find more, many more. And when we do, we'll need these techniques to determine quickly and accurately what they are. This study represents something else planetary scientists have quietly hoped for: vindication of the scientific method against sensationalism. For 5 months, headlines screamed about alien motherships, social media exploded with conspiracy theories, 280,000 posts on X alone mentioned alien technology. But patient, careful measurement, the kind that requires coordinating missions across millions of kilometers and waiting for data to accumulate, that won. The numbers don't lie. The acceleration signature is natural. The mass is ordinary. The chemistry makes sense. Case closed. 3I Atlas is fading now, moving farther from the sun every hour. The spectacular jets that amateur astronomers photographed in November are diminishing as it travels away from the warmth that powered them. Soon it will return to the frozen dormancy it maintained for billions of years before entering our system. And in that state, inactive and dark, it will drift back into interstellar space, carrying with it answers to questions we asked and raising new ones about the nature of objects between the stars. Thank you for watching, and don't forget, if you think this scientific precision matters more than speculation, or if you're disappointed we didn't find aliens, share your thoughts in the comments. And here's my question. When the next interstellar visitor arrives, will we rush to alien conclusions again, or have we learned to wait for the measurements? Until next time,